Hey everybody, welcome to another edition of Accelerated Minutes. Mike Muldowney and Mark Tingley here from Accelerated Machine Design and Engineering. We're at the site where we're building our Galaxy CNC Gantry. It's about 6.5 meters by 7.5 meters. If you want to check out pictures of the whole machine, please check out our LinkedIn page for Accelerated Machine Design and Engineering. But today we're going to focus in this small area right here on parallelism and leveling. You know, Mark, you designed this machine to be incredibly dynamic, have great dynamic stiffness, achieve great velocity and great metal removal rates over a long travel. In order to do that, you have to achieve high standards of parallelism and leveling and make sure that your precision tolerances are met. Can you talk a little bit to us today about how we achieved that parallelism and leveling to have those tight tolerances?
It starts with a good foundation and a rigid base. But you can imagine this runway is almost 40 feet long. So even a rigid base, it's going to flex and warp. So it starts with this first base section that we put down. We have to make sure that this one is flat to the world. So we level this with a precision machinist level in two directions. So in this direction, in this direction. Once we do that, then we lock that in position using these precision fixators and pushers on the side of the runway. Now, to get the next base section parallel to that, we have to use precision levels, but we also have these micro wedge adjusters that we've designed, so we can do 1 micron adjustments up and down and left and right, and then the fixators give us micron level adjustment in the rotation degrees of freedom. Once the bed's level and flat from one end to the other, we double check with levels once again, but then we also run what's called a wire mic. We stretch a wire from one end to the other, and that wire is straight. You hold it in 2 points creates a line. Now we do what's called an electronic mic, and we take a micrometer measurement with the electronic mic between this and the wire. We do that in 2 directions. From there, our runway is just perfectly flat. Now we're ready for rail installation. We can install the rail on the master runway. We install the rail across 2 bed sections. This is a jointed rail, so we have to make sure that the joints are just perfect. Once we install the rail, now what we do is we use the bearing block on the rail and we mount a monument on that. We stretch a wire again and we measure straightness of the rail. We're making micron adjustments of the rail as we go from one end to the other. You can see the black blocks over here, those are pusher wedges. So once we get it in the position that we want it, we lock it down with the wedges. That rail, once we're sure that it's straight and flat, then we come back to this rail and we measure the span between the two. And we set that span with what's called a stick mic. So that stick mic is a micrometer that is gauged off the first rail and we can measure to this. We made fixtures that we can move down the bed, and those fixtures give us micron adjustment of this back and forth, and then we can lock the rails down. Now we're sure that one rail is perfectly straight and flat, second rail is perfectly parallel back to the first rail and flat, and everything's locked in position. Then we come back and we double check that with a laser. The laser is an interferometer that can measure level, it can measure deviation in the vertical plane, deviation in the horizontal plane, and then we check back to each other. Once that happens, then we can mount the feedback scale. We make micron adjustments to the feedback scale to make sure that that's perfectly aligned to our master way. Then we come back in and set our rack and pinion. Rack and pinion is going to be done in another video where we're going to go in depth on this, but the relationship between this and the guide rails is set with the same type of precision that we've been talking about with this. But that's only half the challenge. Now we've got to build the other runway assembly. We have to make sure that that's perfectly level and in line with these rails. So we use what's called water levels for that. The water levels show us, it allows us to take a measurement across a large span and get the height of the two the same.
Wait, so you're saying that this unit shares a lot of the same aspects as like the pyramid or 7 great wonders of the world?
The ancient Egyptians had it right when they built those things. They used the right tools. We use the same techniques here. The difference is we come back and we measure it with the most precise lasers that you can buy. And those lasers, they basically confirm that that first step was good. So that's the final alignment. There's a lot more steps that go into this. If you want to know more about it, stay tuned. We're going to do more of these videos and go into a little more depth on the technology and the techniques that we use. But this is just a good introduction of how we level the bases and runways and how we do rail alignment.
Yeah. Well, thank you all for joining us for another edition of Accelerated Minutes. More to come.